Okay, in this little segment here, I'm going to take this drive that came out of my 1974 Harley spare pump. I'm going to convert this drive into a drive that will not require the timing of this thing for the rotary breather. In this section here, I'm going to use a piece of 303 stainless steel. This is a .875 thickness. I'm using stainless steel in the 303 grade because it is machinable and is very durable. I'll be using a section of this bar to convert this drive into a drive that can just be slid in without regard to timing, and hopefully it'll turn out well. We shall soon find out. This little clip here, what I've done is I've taken a piece of this .875 bar, and I've taken about 30 thousandths off of it, and that way it's going to be a slip fit, about a 1/1000th fit up into here. This piece here is going to be pushed all the way down to the bottom. This piece will become apparent later on, but I want this piece whole because there's going to be some welding involved, and I want to have this mass to absorb heat so distortion will not be a problem. But this piece is going to be pushed all the way down in, and it's going to be welded into this drive, and then I'm going to do some machine work on that piece, and then after that machine work is done on that piece there, then I will machine the windows out for this breather timer, or should I say breather drive. And this little clip here, I'm going to show you something that you need to do. You need to run an abrasive disc or cylinder through here to deburr this, because when Harley made this thing, they didn't worry too much about the insides. Now, I made this little cylinder. It's 1/1000th undercut, so it'll slide down into this thing just like this. Now, what you need to do is take a magic marker or whatever you want and color this thing totally out. I used two colors. I colored the other side too. Now, once you color those things out, you would find the center of these. Now, on the center of this, I would line back up, and you'll notice I cut a 5/16 groove. This is for a key stock. I'm using a 304 key stock stainless, and I'm going to cut a piece that's going to fit into this little groove, and then I'm going to tack weld these here and here on both sides, and then later on I'm going to do a little machine work on that. I'll start cutting these windows out, and I'll show you that in the next clip. In this little video clip, what I have done to this drive, I took some 5/16 304 stainless key stock, and I cut them to fit these windows. If you'll notice that plug I made is installed, and I'm going to weld these 5/16 key stocks in place, and then I will dress them down and turn them down in the lathe to match the rest of the body. Video clip, I'm going to show you the piece after I have welded it in and turn it back down where it's even all the way around. It looks a little on the crappy side right now, but these little pock marks are going to be in a machined out area, and they will not show. Okay, in this little short clip, I decided to show a little interstage operation. These windows are a basic cut. There will be some more machining involved in these windows. They're not quite opened up to the proper degree. And also, if you'll notice in this plug, I bored that hole out so I wouldn't have to do so much metal cutting when I machine those windows. And that little plug will be machined mostly out. There will be a little small ridge left in the almost to the bottom of this right here, and there'll be a couple little short tack welds. The whole reason of this plug was so that I could put these little pieces in the open windows that existed on the drive to begin with. The way I've calculated this out, when I get my windows machined, as one of these supports comes into the window for the original hole that goes back up into the cam case, it'll open up, and by the time this next support comes in, this other support will be starting to engage in the other one. That way I'll have 4 points of support. And the reason why I need to machine this out, I want to keep this thing as close to the original weight as possible, because when this thing turns, because of the way that the electrical cut is, that gearing actually picks up a little bit up on this base, and so therefore this shaft here at the bottom doesn't ride against that plate. And hopefully I'll get to it. Still have a bunch of framework to do, get the machine back together, but eventually I'll get her done. Okay, this is my final installment on the modification to this oil pump drive shaft. If you notice, I've machined 4 windows in there, and the plug that was in the middle has been bored out the most that I can. Since the plug is welded at the top and at the bottom, it's going to act as a drive for the shell. And if you noticed, the legs are a little extra thick because of that plug being in there. So as the drive turns, it'll make this drive more rigid. Now overall, I wound up with a little over ½ square inch more area. At the worst case scenario, if this thing was to be stopped dead in the middle, you would still have a ½ inch total flow area through each side, which would be most probably ¼ square inch. But this thing turns so fast, it's going to be more open than not. So I believe it's going to breathe nicely without having regard to timing this crazy thing. I'm going to give it a try and see what it's going to actually do. But I also plan on using this Parker check valve right here. This is a tube connection. This is a 3/8, but I'm actually going to go with a JIC and a ½ inch. I'm going to adapt that 5/8 hole to a JIC with about a 45. I'm going to run a Teflon wire braided hose from that discharge on that cam case. I'm going to go do a frame tuck, and this ½ inch Parker will go up in that frame. And what I plan on doing is coming off the back side of that frame. Since the old lady made me get rid of my chain oiler, I'm going to turn around and let that thing breathe on top of that chain. That way it give me a little bit of chain lubrication, and maybe not. Only time will tell. But anyway, hopefully this is going to work. I don't mind pulling the pump out now, since I had made the frame modification. But if this works, then bye-bye having to buy gaskets.